Sir, we are live.
Thank you. Hello, friend. Welcome to the Gate Score Booster session of Control System Part 2. So, let me check how many of you are online. So, I can see here that only 6 are currently uh, present here. What about rest? Please inform them. Please. Okay. So, today we have completed part 1. So, in part 1, what uh, we saw that the basics of control system and time domain analysis and the stability analysis, which is Routh Hurwitz criteria and root locus. So the question from that we have already covered in the yesterday session, and we saw a numerous concept, and we have revised from that also. Means we have revised the syllabus through the question. So please come fast, guys, please. All right. So in the control system of part 2, as I said yesterday, that we are going to cover the remaining syllabus of the control system, which is frequency domain analysis, controller and compensator, and what to say, that state space analysis. So, so there are total of 4 questions. There are total of 4 questions. So on the basis of that 4 questions, we are going to revise the remaining syllabus. All right. So no one is commenting, so I hope that all of you are angry, मतलब मेरे से गुस्से हो ऐसा कुछ. Please respond, guys. Otherwise otherwise the session would not be interactive. Please respond. Rahul Kushwaha, no sir. Moise Siddiqui, hello. Yeah, hello Siddiqui. Srinivas Prasad, good morning. Okay, so yesterday BK, okay, good morning. So yesterday I had given you some problem. Have anyone have tried that problem or not? This one, that this question I have given as a homework to you yesterday. I had given this problem to you. Anyone have tried? So if no one have tried, so let me give you the answer for this, or the answer key for that. All right. So what was the answer for this? R, the value of R by C. Okay. Let me show you the answer. So answer for this is minus 0.24. The answer for this is minus 0.24. How many of you got this? How many of you got this answer? Minus 0.24. Mind it, the value that we have to find, that we were to find, is was of R by C, not C by R. So whatever the value you got, that that was C by R. So you need to inverse this value. All right. So you need to take the you were supposed to be taken this ratio as a inversely. All right. So the answer is minus 0.24. Next is that Routh Hurwitz criteria. So the answer for this question is C, that is 2. Now come to next question. Sorry. I think I have already shared the notes with my team. So my team will confirm you whether the link uh, is provided or not to you. I think the link has already given in the chat box itself. Okay. So the question number 3 is this one. Let me increase some font size. Sorry. Okay. So the answer for this question is Again, option C. And for question number 4, the answer is D. All right. So I hope that all of you attempted the question and got the correct answer for all of the 4 questions. All right. So with that note, let us go to part 2 and let us start solving the problem and analyzing the problem and revising this syllabus as well. All right. So who am I that you have already know knew this that I'm Nikhil Gaurav and I'm handling this subject like a control system and power electronic and measurement. All right. So let us move to question number 1, which is Bode plot, and this topic is one of the very important topic for the GATE exam point of view. Means in every year you see this question from this topic. All right. So the transfer function for the given Bode magnitude plot will be. सर ये क्लास जेई के लिए बेस्ट है। एसएससी जेई और आरआरबी जेई के लिए हमने जो है पहले से ही लेक्चर जो है वो बना के रखे हुए हैं। सो आप द गेट एकेडमी इंग्लिश चैनल मीन्स दोनों को सब्सक्राइब कर लीजिए, और जो ये जो एसएससी जेई का और आरबी जेई का जो लेक्चर है वो आपको द गेट एकेडमी हिंदी चैनल में आपको दिख जाएगा कंट्रोल सिस्टम के। एनी हाउ इसके सर्टेन पार्ट जो है वो आपको एसएससी जेई में देखने को मिलेंगे ही मिलेंगे। ठीक है। सो ये एसएससी जेई आरआरबी जेई इवन अदर स्टेट एग्जाम के लिए भी ये काफी बेनिफिट करेगा। ऑलराइट, सो let us move to the question and try to solve this problem. All right, so the question says that the transfer function for the given Bode plot, first let me please tell me whether the background is good or not. I have changed the color of the background. It is like light green. All right, please confirm me once the background is good or I need to change that. Anyone, please, the background is good or should I change this? Okay, the transfer function for the given Bode magnitude plot will be. So this is your transfer function. Sorry, this is your Bode magnitude plot, and we need to find the transfer function for this. All right. All right. So any guesses which of the following option is incorrect or may be incorrect by seeing the option and the Bode plot? Everyone has to answer. Which of the following answer is, are, or may be incorrect? Everyone, please be fast. Please be fast. C and D are incorrect. All right. So Michael says C and D. Srinivas says C and D are incorrect. All right. Others? So C is definitely incorrect, but there are chances that D may be correct. D may be correct. Chances that, but definitely option C is incorrect. It is because, or I will tell you later why these options are incorrect. All right. So first, let me copy this diagram and all right. So this is your diagram. So we need to frame the or we need to find the transfer function. For the transfer function, we need to follow we need to follow the certain steps. First step is we need to look the initial slope from the Bode magnitude plot, and I hope you all are knowing that the Bode magnitude plot is not the exact one. This is asymptotic Bode magnitude plot. What does the meaning, sorry, what is the meaning of asymptotic? Asymptotic means it is a straight line. Asymptotic is a straight line by the help of which we are going to plot our exact Bode plot or exact magnitude plot. Understood? Means this is an approximate straight line. So your that exactly magnitude plot maybe look like in this fashion. All right. So this one is asymptotic, and this one is your phase. All right. So let us move ahead and find the transfer function. So the initial slope is from the Bode magnitude plot is of minus 40 degrees. So initial slope is of minus 40 dB per decade. All right. So minus 40 dB per decade is also equal to minus 12 dB per octave. Sir, what is the meaning of this? I mean to say that one decade means the ratio of the consecutive frequency omega 2 by omega 1 should be 10. Then must be 10. Then it is known as one decade. And if the ratio is, sorry, this is omega 1. If ratio is omega 2 by omega 1 is a multiple of 2 1 octave. So if there is a pole, then it will provide a negative slope, and if there is a zero, then it will provide a positive slope. So I hope all of you are knowing this. All right. So for pole minus 20 n dB per decade slope will give if the frequency is in the ratio of 10, and minus this is equal to minus 6 n dB per decade. All right. Where n is, or let me change, where n is number of OLTF poles. All right. Now plus 20 n dB per decade is equal to minus 6 plus 6 n dB per decade. Sorry. Actually, sorry. This is octave, na? This is octave. Where n is number of OLTF zeros. All right. So this sort of information you need to know. Now, now from the slope, I can say that initial slope initial slope is of minus 40 dB per decade. That means the number of poles at origin will give you the initial slope. Or let me correct myself. If the slope is of decaying nature, means if the initial slope is of 0 dB per decade, then there is no pole and zero at the origin. But if the initial slope is of minus 20 or plus 20 dB per decade, or minus 40 plus 40 dB per decade, then definitely there is a pole at origin or a zero at origin. So by seeing the Bode plot, I can say that as the initial slope, that or the starting slope is of minus 40 dB per decade, means minus sign signifies that there is a pole. And how many pole are at origin? So number of pole at origin. If one pole, uh, if there is one pole, then the contribution of the slope will be minus would be minus 20 dB per decade. But the slope is of minus 40 dB per decade, then definitely there is two pole. Then definitely there are two pole at origin, and the contribution of the slope for that pole will be minus 40 dB per decade. So all of you are clear it or not? Everyone cleared or not? So means initial slope in in s domain it is given by 1 by s square. So let us move ahead, and we need to find the extra term. All right. So this is the one term which is which we will see in our transfer function. Now second, now as Bode plot is starting from uh, prior to the omega equal to 4, and at omega equal to 4 look here, the slope is changing. All right, slope is changing. The slope is changing from minus 40 dB per decade to 0 dB per decade. That means the slope is increasing from minus 40 to 0 dB. That means at omega equal to 4, at omega equal to 4, there is a 0. There is a 0. So let us first check how many poles how many poles or how many zeros are present, or how many corner frequency are present. So corner frequency, what is the meaning of corner frequency? The frequency at which the slope are changing, the frequency at which the slopes are changing. So at omega equal to 4, at omega equal to 4, and at omega equal to 10, and at omega equal to 32, and omega equal to 40, and omega equal to 52. So at all these places, your slopes are changing. Your slopes are changing. That means this is treated as corner frequency. All right. So these all are treated at corner frequency. So let us find the how many poles or zeros are present at corner frequency. So at corner frequency, omega equal to 4 radian per second. So anyone please tell me how many poles or zeros are present at the corner frequency. So I have already told you that as slope is increasing from minus 40 to 0 dB, so there are two zeros. All right. So which are given by del of s, that is how many slopes what are the change at corner frequency. So a slope after 4 means slope after corner frequency, that is omega equal to 4 minus previous slope just before corner frequency. So after the omega equal to 4, the slope is 0 dB per decade, and previous slope is of minus 40 dB per decade. That means plus 40 dB per decade. That means at omega equal to 4, there are two zeros. All right, and it is given by, hence it is given by 1 plus. Please look here, it is given by in a standard form. It is always represented in a standard form. So 1 plus s by 4 to the whole square. All right, so this is a transfer function. Now third, at corner frequency, omega equal to 10 radian per second. So I'm going to write it directly. I'm going to write it directly. All right. So at omega equal to 10, let us go and check. So plus 20 dB per decade, previous 0. That means slope is increasing. So total change यहाँ पे क्या होगा? Plus 20 dB per decade. Hence 1 plus s by 10 whole square. All right. Now come to fourth. At corner frequency, omega equal to 20, I guess. Sorry, 32. So at 32, slope is decreasing from plus 20 dB to 0 dB. That means total change is 32 radian per second. All right. So total del S is minus 20 dB per decade. Hence it is given as 1 upon 1 plus s by 32. Okay, Siddiqui. Sorry, I think it is as Siddiqui said. This is plus 20 na, so power should be 1. All right. So 1 upon. Thank you, yeah. All right. So 1 upon 1 plus s by 32. Now come to fourth. At corner frequency, omega equal to 40 na. So 40, the change in slope is of again minus 20, and at 52 there is again a change of minus 20. So at 40 at 40 at 40 radian per second, del S is again minus 20 dB per decade. All right. So hence it is given as 1 upon 1 plus S by 40. Similarly, the last one is at corner frequency omega equal to 52 radian per second. Del S is again minus 20 dB per decade. All right. So 1 upon 1 plus S by 52. सॉरी मेरा S जो है थोड़ा सा 5 जैसा दिख रहा होगा. So let me change it. All right. So यहाँ तक till here we have find the how many poles and zeros are present at each and every corner frequency. So the next step is we need to find the transfer function, and it is given as the function of k product with a function of s. So k times of the number of poles at origin was 2. Then at 1 plus s by 4 there are 2 zeros, and 1 plus s by 10, sorry, 1 plus s by 10 there is 1 0 again. Then 1 plus s by 32, let me check, 1 plus s by 32. All right, so 1 plus s by 4 whole square, then 1 plus s by 10, then 1 plus s by 32, then 1 plus s by 40, then 1 plus s by 40, then 1 plus s by 52. So this is your transfer function. The unknown quantity is only here k. So we need to find the value of k here. All right, we need to find the value of k. This is only unknown. So for this, the method I use or the method which I use here is somewhat different. Means I am going to use the approximation here. ठीक है. So many of the faculty use this formula, y equal to mx plus c, means straight line equation. But my approach is some sort of different. Look here, as you know, the Bode plot is asymptotic Bode plot. So what are those approximation? Look here. Suppose if your transfer function consisting of this expression 1 plus j 0.999 till so on. All right. So I can approximate, or let me change the color. So I can approximate this as equal to 1. All right. Please see here. All right. This is very important point. All right. Then 1 plus j1. This is also equal to 1. All right. And 1 plus j 1.000 so on till 1. So this is equivalent to j times of 1.000 till 1. So I hope you all are knowing this, that how I am approximating this. Means I am comparing the real part with the imaginary part. All right. How means my real part is always I'm going to compare with my imaginary part. So it is no matter how your imaginary part is small or larger. If imaginary part is little bit bigger than your real part, then we will take imaginary part, and if it is equal, then it will not matter. But if it is lesser, means if imaginary part is smaller, then we will consider 1 itself. All right. So this is your approximation. Now let us go and find the transfer function. So for this we need to find the magnitude, that is m of dB, and at any one corner frequency or at any one frequency. Means at exactly, or at least at one corner frequency, we must be knowing a magnitude. So at omega equal to 6, see here, at omega equal to 6, we are knowing the value of magnitude of the transfer function, which is 0 dB. So this is 0 dB. All right. So look here. Suppose my transfer function is k by s square, and later on, if I found that my k value is here k1, so so everyone please tell whether k equal to k1 is same, or I will get exactly the same value for this or not also. Means for this transfer function and for this transfer function, the k equal to k1 will be both same or not. If I eliminate this term, this term, this term, this term, and this term, so I will left only with this term now. So suppose I found the value as k equal to k1. So can this value and this value total, this one, will be same or not? Yes, same, exactly. So what I mean to say here that what I mean to say here that if you add pole or zero, if you add pole or zero at origin or at finite value, it will not going to alter your k value. Means it remain always unaltered. All right, it will remains same. So k value will remain as it is. So what I will do, I will take the transfer function only of this term, t of f upon equal to k by s square. All right. So the transfer function, the transfer function value or the magnitude value at omega equal to 6, at omega equal to 6 is given by magnitude k by s is j omega na, then whole square, all right, at omega equal to 6. So this will be equal to k by 6 square or k by 36. But mind it, this is magnitude, and the value given, sorry, and the value given in the vertical axis is of dB. Then we need to convert magnitude in dB. So for that, I will take 20 log to the both side with a base of 10. Transfer function magnitude value at omega equal to 6. This is also equal to 20 log 10. What I have done here, that I have taken 20 log on both sides. So k by 36. And we know that this value is 0 dB, 0 dB. So 20 log 10 k by 36. All right. So the value of k is, so the value of k is, this implies the k is equal to 36. All right. So just substitute the value of k here in your transfer function. So let me copy this. All right. So we have obtained the k value, and let us substitute here k equal to 36. So this is square, this is 1, this is 1, this is 1, and this one is also 1. All right. Understood or not? All of you are getting it or not? So this is our transfer function. So let us go and check the option. 36, 1 plus s by 4 whole square, 1 plus s by 10, s square, 1 plus s by 32, 1 plus s by 40, 1 plus s by 52. So option A is the correct option for this question. Look here, option D is not correct. It is because this is not in the standard form. This is not in the standard form. But if you write in the time, so if you want to write your transfer function in pole and zero form, then you need to take 4, 32, 10, 40, and 52 from all the factor. Means 32 into 36 into 32, 40, 52 divided by 4 square into 10. So this will be equal to s plus 4 whole square, s plus 10, then s square, so s plus 32, s plus 40, so s plus 52. All right. So this value 40 will be going to cancel, and 4, this is equal to let us say 13. So when you simplify this, means 36 into 32 into 18, so this value will somewhat greater than 36. So option A probably be wrong. All right. So I hope all of you got the concept. So how we are doing this. All right. All right. If you like, please say hi. Otherwise, if you didn't like this, then also say yes, sir. It is good for my sake. All right. I'm seeing that no one of you participating in the session. Please, please, please be attentive and participate as much as you can. And please share the session with your friend. Please tell them to join as soon as possible. All right. Can we move ahead? Can we move ahead? All right. Else, please reply. Everyone has to reply. All right. So see here, the question number 2 is also from the Bode plot. And mind it, this is one of the important topic, not exactly very important, but what you say that the concept which I am going to use here is really one of the very important concept. All right. So as you see here, the question says an asymptotic Bode phase plot. So this is a new topic that I have taken, and the question from this has come one time, which is in EC branch. Uh, the year is 2016. So please listen me very carefully. The concept here is little bit different compared to your magnitude plot. All right, the concept which I'm going to deal here is somewhat different, and uh, and you need to be very attentive in this phase plot. All right, so the Bode phase plot for the open loop transfer function g of j omega is 10 uh, 0.01 j omega plus 1 whole divided by j omega 0.1 j omega plus 1, then j omega plus 1 is. So anyone have any idea how to draw phase plot or how to find the phase plot from the transfer function, or any wild guess कि सर ये ऑप्शन करेक्ट होगा या फिर ये ऑप्शन रॉन्ग होगा? एनीवन? All right. So let me solve this. So your g of j omega, g of j omega, g of j omega is given as 10 10 times of j 0.01 0.01 omega plus 1 whole divided by j omega whole divided by j omega. The next is 0.1 j omega, 0.1 j omega plus 1, and j omega plus 1. So you know that j omega is nothing but s. So 10 times of, or let me change the color, 10 times of 10 times of. So can I write 1 plus s by 100? All right. Is it clear? S 1 plus s by 10, and here 1 plus s by 1. All right. So that means in our transfer function, the number of poles, one pole at origin, one pole at origin, and one at omega equal to 1, there is also one pole, and at omega equal to 10, there is also one pole. All right. And the number of zeros, there is one zero at omega equal to 100. There is one zero at omega equal to 100. All right. So the approach we are going to use here is somewhat different. For this, let me take some example, and with the help of that example, I will show you how we are going to find your Bode phase plot. All right. So please be attentive. The approach we are going to use here is very different from your magnetic plot. So let me take some example. Example 1. Suppose if your transfer function, that is g of s, is 1 upon 1 plus s by 10. All right. So here we also use the concept of asymptotic Bode plot. Means what I mean to say, in asymptotic Bode plot, we need to compare the imaginary part and the real part. Look here, 1 plus j omega tau, 1 plus j omega tau. this is equal to this is equal to 1, this is equal to 1 whenever omega tau is less than equal to zero point 0.1. All right, where 1 upon tau is, or 1 upon tau is, sorry, 1 upon tau is corner frequency, where 1 upon tau is corner frequency. All right, now if 1 plus j omega tau, this is equal to j omega tau if omega tau is greater than equal to 10. All right, similarly where 1 upon tau is corner frequency. Now for if 1 plus j omega tau, this is equal to 1 plus j omega tau whenever your omega tau is between zero point 0.1 to 10. Similarly, omega 1 upon omega tau is your corner frequency. Please listen very carefully. All right. I know this is new topic to you. Plus, sorry, this one is new topic to you, and you will never know that from where the gate authority will going to ask you. So we will have to be prepared for each and every concept. All right. So this is new topic. So please listen. Please be attentive and please be patient. All right. So this is your certain approximation. All right. So 1 upon plus s by 10. So corner frequency here is 10. All right. And there is one pole only. So in this case, what I will do that 1 plus j, sorry, let me draw the graph first. All right. So look here. From here, can I say omega equal to omega less than equal to 1 upon, sorry, 0.1, or let me change the color itself. Omega equal to 0.1 upon tau. This is your omega value. All right. This is your omega value. All right. So at omega equal to 10, at omega equal to 10. So we need to take the 1 decade before the corner frequency and 1 decade after the corner frequency that I wrote here. All right. 1 decade before the corner frequency and 1 decade after the corner frequency. 1 decade before means here 1 will come, and 1 decade after means here let me say 100 will come, means 1 decade before and 1 decade after. So 1 decade before, your transfer function will be real part. Na? Your transfer function value will be real part, and you know 1 plus g of s equal to, or let me write it here, g of s, this is equal to 1 upon 1 plus s by 10, and g of j omega, this is equal to 1 plus j omega by 10. So if omega is less than 1, then it is only real part, then it will only be a real part, which is g of j omega, this is equal to 1 by 1, which is 1. So angle here will be 0 degree. So whenever omega is less than 1 radian per second, or less than equal to 1 radian per second, the value or the plot is of straight line only, means 0 degree. This is your phi, this is your omega, and this is your 0 degree. All right. Let me say this is plus 45 degree, plus 90 degree, and here minus 45 degree, and here minus 90 degree, and so on. All right. Now come to next. All right. Then g of j omega, this is equal to 1 plus 1 upon j omega by 10. So this is equal to 1 upon j omega by 10 whenever your omega is greater than equal to 100 radian per second. And you know that 1 by j is purely imaginary, that is minus j 10 by omega. As this is purely a imaginary part, so angle here, that is g of j omega, is equal to minus 90 degree. All right. So at omega greater than equal to 100 radian per second, your plot will be 90 degree always. All right. Understood? This is always 90 degree per decade. Now look here, between 1 to 100, you will going to get a straight line because there is no approximation. You will going to get approximation because there is no approximation between 1 to 100. See here. See here. At 1 plus j omega tau, if omega tau is between 0.1 to 10, then there is no approximation, and for this you will get the straight line. So we need to find the slope value for this. We need to find a slope value for this. So look here, slope value is given by let me change the color. Slope value is given by, look here, slope value will be given by, look here, at omega equal to 10, the magnitude is minus 45 degree, and at omega equal to 1, your degree or the phase angle degree is 0. All right. Then log of at 45 degree frequency is 10 minus log at 0 degree frequency is 1. So this value will be minus 45 degree per decade. The decade is come from here. See, the ratio is 10. So this is minus 45 degree per decade. So I hope all of you have got the point. So this is minus 45 degree per decade. All right. And the slope here is 0 degree per decade. Similarly, the slope here is also 0 degree per decade. All of you got it or not? Everyone has to answer. All of you have got it or not? This is very challenging as this is a new topic to all of us. This is new to you. This is new to us also. All right. So this is the some what to say some idea about how we are going to plot the Bode phase plot if there is one pole in your transfer function. So see here, I'm going to plot directly. Wait, let me take the axis. So this is your axis here. So omega, this is phase angle, yeah, g of j omega. You can say that the corner frequency we have at 100, at 1, and at 10. All right. So at 1 we have one pole, and at 10 we have again one pole, and at 100 we have 1 0. All right. So one pole and one pole again. So for one pole, the angle will always be, for one pole the angle will always be, sorry, let me value also, minus 40 plus 45 plus 90 degree plus 135. All right. Here same, minus 45 degree minus 90 degree minus 135 degree minus 180 degree. So will be minus 225 degree, and here minus 270 degree. Wait. All right. So see here, initially there is one pole at origin. That means it is purely a real part, and you know that one pole will always give a phase angle of 90 degree. Means if they 1 by j omega, sorry, j omega will give the phase angle as plus 90 degree for omega 0 to till infinity. It is because there is no real part. Similarly, 1 by j omega will give the phase angle of minus 90 degree from omega equal to 0 to infinity. All right. So I hope this is clear to all. So initially the slope is of 0 degree per decade. The slope is of 0 degree per decade. Now come here at omega equal to 1, at omega equal to 1, so we need to take the frequency such that one decade prior to this and one decade after to this. So one decade prior to one means, or let me remove this so that I can have equal distance of all the poles. So at omega equal to 1, so let me take one decade prior to this. So point 1, this will be 1, and one decade after to this is 10. All right, at 1 we have one pole, and at 10 we have one pole. All right, so this is your exact value of corner frequency. Now at omega equal to 10, again we have one pole, so one decade prior to this, one decade prior to this, and one decade after to this. Or better, let me draw the phase plot of only 1 plus s by 1. All right, I am drawing the phase plot for this transfer function only. So prior to this, wait, so prior to this, your phase angle will be your slope will be 0 degree per decade. Why it is being weird? Okay, all right, let me check. All right, so come here. So prior to one decade before, means one decade before the corner frequency here is 1 na? So it will go 0 degree per decade till point 1, and after this it will reach, and after this it will reach, after this it will reach a straight line, which is the slope which is of minus 45 degree per decade, and it will go till one decade after the corner frequency, which is at 10, and after this it will reach, sorry yaar, why this is behaving weird. All right, see here, so we will get at omega equal to 1 there is one pole. So and at after one decade before the corner frequency, that is at 10, it will reach minus 90 degree, and this is your maximum slope, and after that your slope will going to be 0 degree per decade. All right, all right, all of you are clear it or not? Now look here, at omega equal to 10 there is again one pole, so one decade prior to that, slope will be 0 degree per decade. It will go till 1. At 1 it will going to decay at a rate of minus 45 degree per decade, and it will go till 100. It will go till 100. All right, it will go till 100, one decade after the corner frequency. So the slope for this is minus 45 degree per decade. Here all slope is minus 45 degree per decade. Here the slope is 0 degree per decade. Here also the slope is 0 degree per decade. All right, now next is at omega equal to 100 there is 1 0. At omega equal to 100 there is 1 0. So one decade prior to that means at 10 the slope will going to be start, and the slope value is of plus 45 degree per decade. So it will start from 10. At 45 the angle will be at 100 degree, means at corner frequency the slope is minus 45 degree per decade, or you can say that at omega equal to 100 the slope angle will be of plus 45 degree, and it will go till 1000. It will go till 1000 means one decade after the corner frequency. And after 1000 your slope will going to be constant. Your slope will going to be constant. All right, so this is 0 degree per decade here plus 45 degree per decade. All right, Wait, let me change the color first of all. So after that, we will going to draw our phase plot. So listen me very carefully. All right. Let me change the color first. Now see here, from omega equal to 0 here, from omega equal to 0 till omega equal to 0.1, till omega equal to 0.1, till here, there is no change in the slope. There is no change in the slope, means 0 degree per decade. So the value is here, is given by only the number of poles at origin, which is of minus 90 degrees. So the slope will start, or the phase will start from minus 90 degree, where omega equal to 0, and it will go till omega equal to 0.1. It will go till omega equal to 0.1. Now after omega equal to 0.1, after omega equal to 0.1, there is one change in slope, which is of minus 45 degree per, see here, there is change in slope now, so minus 45 degree per decade. So from here till here, the slope will only be minus 45 degree per decade. So your slope will, so it will going to decay in this fashion, and it will reach, at omega equal to 1 minus 135. It will reach minus 135. It is because your slope is decaying, decaying with minus 45 degree per decade. All right, see here, at omega equal to 0.1, 1 decade means at omega equal to 1, the change should be of minus 45 degree. So minus 90 minus 45, minus 90 minus 45, that means minus 135, means your slope will reach minus 135 at omega equal to 1. All right, all right. Now come to at omega equal to 1, at omega equal to 1, at omega equal to 1, uh, there are two poles, this one and this, means there are two slope, sorry, there are two slope. First slope is of minus 45 degree per decade, and exactly this will give the slope of minus 45 degree per decade. The total slope is addition of these two, which is minus 90 degree per decade, So your slope will going to change from minus 45 to minus 98. Mind it, you will not going to add minus 90 to your previous value, means minus 90 minus of minus 45. So this is somewhat different from the phase plot, so you need to take care of that only particular reason. So for that particular reason, you will going to add your slope, and with that slope we will going to find your the phase plot. So the slope will be of minus 90 degree, means for 1 decade, means you will going to add this one, so minus 90 degree per decade. What does it mean? What does it mean? Sorry, what does it mean? So in 1 decade, the change should be of minus 90 degree only. So look here, omega equal to 1, the slope is your starting, and 1 decade after, means at omega equal to 10, the phase angle should reach to, or the change should be of minus 90. So look here, so it will start from minus 135, then add this minus 90, add this minus 90, so it will give you minus 225. So exactly at omega equal to 10, your phase will reach till minus 225. All right. Now next is up to omega equal to 10, we have reached. All right, now after omega equal to 10, the slope contribution here is 0 degree, for this minus 45 degree, and for this plus 45 degree. So the addition of whole, the addition of whole will be 0 degree minus 45 plus 45 means 0 degree per decade. The resultant will be 0 degree per decade. So at omega equal to 10, the slope will start as 0 degree per decade and it will reach till omega equal to 100. Till omega equal to 100. Now, after omega equal to 100, after omega equal to 100, the slope contribution for this is 0 degree per decade, but here plus 45 degree per decade means total change in slope is of plus 45 degree per decade. Means at omega equal to 100, your slope will be of plus 45 degree per decade and it will go till 1000. It will go till 1000. All right, go till 1000. And after that, after 1000, see here, after 1000 means after here 0 degree per decade, 0 degree per decade. So the total slope will be of 0 degree per decade means your slope will going to be constant exactly after omega equal to 1000. All right. All right. So these are some methods or the concept which you are going to use in your Bode phase plot. So the slope here is of 0 degree per decade. Here slope is minus 45 degree per decade. Here slope is of minus 90 degree per decade. Here slope is of 0 degree per decade. Here slope will be of plus 45 degree per decade. All right. And here slope is of 0 degree per decade. All right. So this is your exactly, or sorry, not exactly, this is your asymptotic Bode phase plot. This is your asymptotic Bode phase plot. So I hope this is really cumbersome and it is really difficult and challenging to understand. Please watch the lecture once again, once it will going to upload. I'm definitely sure that you will definitely going to get the concept. All right. As it is right now, it is somewhat difficult as this is new topic to you, but after once the lecture session got uploaded in our YouTube, so please go and watch this session again. Definitely you will going to crack the concept here. All right, so let us go and check which of the following option is correct. So slope will be of 0 degree per decade starting from minus 90, then minus 45 degree. From 1 to 10, the change should be of minus 90, but here it is minus 135. So option A is wrong. Similarly, option B is also wrong. Option C is also wrong, and option D is correct. Option D is correct. All right. All right. So as you see here, the change in slope is not at the corner frequency. The change in slope is not at the corner frequency. Rather, the change in slope start 1 decade before the corner frequency and it will end 1 decade after the corner frequencies. So at omega equal to 10, there was a corner frequency for this example. All right. So these are the certain concept from the Bode phase plot. Now let us move to next question, which is which is from Nyquist plot, All right. So I know this is one of the very challenging topic for the student. Nyquist plot, the question that have already come from in the GATE exam was really conceptual and very challenging. But let me tell you, this is one of the easy topic from the control system. Control system, this is one of the very easy topic. All right. So let us go and check our question. What we need to find: the polar plot of all the pole minimum phase system is shown in the figure. So this is your phase. This is your polar plot all right, and the diagram is shown here, or the plot is shown here. So what we need to find, we need to determine the open loop transfer function, and the second bit is number of encirclement about the critical point and origin. All right, number of critical point at the origin. So as you know, the Nyquist plot from omega equal to 0 to omega equal to infinity, from omega equal to 0 to omega equal to infinity, is known as polar plot. All right, so this is not the Nyquist plot, rather it is a polar plot as it is given in the question. And it is also given that the transfer function consists of your all poles, means in transfer function there are no terms of zero. All right, and this transfer function is minimum phase system. So minimum phase system means all poles and zeros are lies in the left hand side of S plane. So all pole means no zeros in transfer function, and minimum phase means no pole and zero in the right hand side, means no pole and zeros in the right hand side, rather all pole and zero in the left hand side. So let me copy this plot so that we have some space. All right, so can anyone tell me from the plot, from the plot uh, what is the type of system? Type of the system means the number of poles at origin. What is the type of system? Everyone has to answer. Please, I am requesting you, please participate as much as you can do. And everyone has to tell what is the type of the system. Moiz Siddiqui 2, Rajsekhar Natarajan 0, Michael Toro 0. All right, uh, Michael and Rajsekhar, you are correct. The type of the system is 0. Siddiqui, if the type is greater than equal to 1, if the type is greater than equal to 1, then your polar plot will start uh, from infinity, means magnitude will be infinity at omega equal to 0. So look here, if g of s equal to 1 upon s, the type of the system, that is n equal to 1. And let me take another example, 1 upon s plus 1. So here type is 0. So g of j omega, this will be 1 by j omega. So g at j omega equal to 0, 1 by j 0. The magnitude here is infinity. All right, and for this g of j omega 1 upon j omega plus 1. So at omega equal to 0, this will be 1. So magnitude will be 1. So at omega equal to 0, for type n equal to 1, the magnitude is infinity. And if type is 0, then magnitude will be finite value. Rather, it is finite value. So look here, at omega equal to 0, the slope is finite value, which is, sorry, not slope, the magnitude. At omega equal to 0, the magnitude of g of s, h of s is 2. That means the type of the system is 0. All right, Siddiqui, it is clear to you? All right. Now, anyone, please tell me how many poles are present in the transfer function? How many poles or how many terms are available in the transfer function? Please answer me. How many terms are available, are present in the transfer function? As it is given that there is no zero in the transfer function, that means all terms should be of poles. All right. So the total number of poles, is given by the phase at omega equal to infinity, phase angle at the omega equal to infinity. So look here, g of s equal to 1 upon j omega plus 1, j omega plus 2. So at omega equal to infinity, at omega equal to infinity, one pole will contribute minus 90 degree. All right, one pole will contribute minus 90 degree, but here two poles, but here are two poles. So minus 90 minus 90. It will give total minus 180 degree. So two pole will contribute minus 180 degree at omega equal to infinity. So come here and look at omega equal to infinity. At omega equal to infinity, this is 0 degree, minus 90 degree, minus 180 degree, minus 270 degree. So at omega equal to infinity, your plot will going to be entered at minus 180 degree. That means there are two poles in our transfer function. There are two poles in our transfer function. So let me write the transfer function as transfer function. This is equal to k upon, as there is no pole at origin. So 1 plus j omega t1 and 1 plus j omega t2. All right, and all are minimum phase. That means t1 is greater than 0, t2 greater than 0, as well as k greater than 0. All right, now the information from the plot that we are getting, that omega equal to 0, magnitude is 2 and phase angle is 0 degree. Also at omega equal to infinity, magnitude is 0 and phase angle is minus 180 degree. Also look here, at omega equal to 2, at omega equal to 2, the magnitude minus 2, this is 2, and phase angle is minus 90 degree. So we need to find the unknown value, that is t1, t2 and k. All right, now look here, the magnitude of transfer function at omega equal to 0. So substitute omega equal to 0 here, you will get k value, and omega equal to 0, the magnitude given is at 2. That means k value is 2. All right, it is clear to you? Now the transfer function value at omega equal to 2 is given as minus 90 degree. So find the find the phase angle for this transfer function. So minus tan inverse omega tau 1 minus tan inverse omega t2 or else tau 2, this is equal to minus 90 degree. So tan inverse omega, this is not tau t1. All right, both are same, both are same. So inverse omega t2, this is equal to plus 90 degree. So tan inverse a plus tan inverse b is equal to tan inverse a plus b, means omega t1 plus omega t2 whole divided by 1 minus omega square t1 into t2, and this value is at omega equal to 2. All right, so you know that tan inverse infinity is 90 degree. That means 1 minus omega square t1 t2 at omega equal to 2, this should be equal to 0. All right, it is because at, if denominator part is 0, then something divided by 0 is infinity. All right, so that is why I have equated denominator part equal to 0. So 1 or omega square is equal to 1 upon root over t1 by t2, or you can say that t1, sorry, not omega square, omega t1 by t2, this is equal to 1 upon omega square, and this value is at 2 na, so 2 square, so this is equal to 1 by 4, so 0.25. So you know that t1 into t2 is 0.25. So the transfer function, that is k 1 plus s t1 1 plus s t2, I can simplify it as k upon 1 plus s times of t1 plus t2 plus s square t1 t2. All right, t1 t2. Now we have got the k value, we have got t1 and t2. Only the unknown term is t1 plus t2. So how do we get this? So for this we will going to use the magnitude condition. So look here, in the transfer function here, in the transfer function, we will equate, we will find the magnitude. So magnitude of k divided by root over 1 plus omega t1 whole square root over 1 plus omega t2 whole square at omega equal to 2. The magnitude is 2 na, the magnitude is 2 na, and k value we have already got, which is 2. So this value is at omega equal to 2. So 1 plus 2 t1 whole square 1 plus 2 t2 whole square, this is equal to 2. So this two will going to be cancelled out. So root over 1 plus 4, or I think it will be somewhat cumbersome, or let me write omega value as 1 upon t1 and t2. Look here, omega value is here root over 1 upon root over t1 and t2 na. This is at omega equal to 2. So k root over 1 plus, this is 1 upon root over t1 t2 times of t1 whole square times of root over 1 plus 1 upon root over t1 t2 times of t2 whole square. This is equal to 2 as well. So on simplifying this, we will get 2 root over 1 plus t1 by t2, t1 by t2. Here also we will get root over 1 plus t2 by t1. This is equal to 2. So on simplifying, we get 2 upon t1 plus t2 root over t1 into t2. This is equal to 2. All right. So t1 plus t2 is equal to root over t1 into t2, and root over t1 into t2 is 1 by 4. So this is equal to half, which is equal to 0.5. So all value we have got. So substitute in your transfer function value. So this is equal to, sorry, so this is equal to k is 2 1 plus s times, so t1 plus t2 is 0.5 plus s square t1 and t2 is 0.25. So on simplifying this, we will going to get 8 upon s square plus 2s plus 4. So this is our transfer function. So this is our transfer function. So let us go and check. 8 upon s square plus 2s plus 4. So the correct answer for this part 1 is option B. All right. Now the second bit is number of encirclement about critical point and about the origin. For this, let me have one more extra page. All right. So first bit is number of encirclement about critical point. So what is the critical point in control system? It is 1 plus j0. Okay. So for that we will going to use the Nyquist plot. So see here, this is your polar plot now. This is your polar plot, means at omega from 0 plus 2 till omega equal to infinity plus, it is already given. Now from omega equal to infinity plus to infinity minus, for omega equal to infinity plus to omega equal to infinity minus, if magnitude is 0, then for this also magnitude is 0 for all frequency from omega to infinity plus to infinity minus. So this is also equal to 0. Now from omega equal to infinity minus to 0 plus, we will take the mirror image of polar plot. So it will start in this fashion. It will go like this. It will cut this and it will join the omega equal to 0 minus. And as you know, from 0 minus to till 0 plus, it will give the number of encirclement about the critical point. And that will be equal to number of poles at the origin. As in our problem, there is no pole at the origin. That means there is no encirclement about the means there is no encirclement of the infinite radius. All right. So this is your complete Nyquist plot. This is your complete plot, or rather you will say it as Nyquist plot. All right. Now we need to check the point minus 1 plus j0. So this is your critical point minus 1 plus j0. So number of encirclement is, that is n equal to 0, and we know the formula, and we know that n equal to p minus z. This is the stability criteria from the Nyquist stability. All right. So n equal to 0, p is open loop poles, and the open loop poles in our problem is 0 minus z. So z equal to 0. As z equal to 0, this means that closed loop system is stable. All right. Now let us move and find the second bit. All right. So second bit is number of encirclement about origin. All right. Please be attentive, guys, as the formula for both critical point and the encirclement about the origin both are same, but there is certain difference in the notation. See here, P is number of open loop poles in right hand side. All right. And Z is number of open loop zeros in right hand side. All right. So in our problem, the number of open loop poles is 0, and number of zeros in the right hand side means number of open loop zeros in right hand side, this is also 0. So number of encirclement about origin is also 0. Mind it, this is approximate. This is approximate Nyquist plot. If you want to find the exact Nyquist plot, it will be like this. This is your exact Nyquist plot. So it will never encircle the origin. So let us move back to the question and see the option. Number of encirclement about critical point is 0, and origin, this is also 0. So option A will be the correct option for this. All right. So with this, we have completed the Nyquist plot and the Bode plot. The last one is from state space analysis. So let us go and check the problem based from the state space analysis. So let me reduce some width. All right. So this is your next question from the signal from the state space analysis. All right. So what we need to find here, see, consider the signal flow graph as shown in the figure and find the following. So this is your signal flow graph. For this, we need to find first state space model. All right. Second, we need to determine the stability and the nature of the system. Third one, transfer function value. And the last one is the steady state error due to step input. All right. Now, look here. Let me copy this signal flow graph. All right. So state space model, state space model is given by x dot or d by dt of x n cross 1. This is equal to matrix A times of x, where x is state variable with dimension of n cross 1 plus b times of u. All right, b times of u, and y equal to 8 c times of y equal to c times of x. All right. So x dot is a differential vector, a is system matrix, x is variable, b is input matrix, u is input vector, y is output vector, c is output matrix, and x is state vector. So a a matrix is always a square matrix. A square matrix means its row and column will always be equal. All right. Now see here, n n is number of variable, n is number of variable. So number of variable means x1, x2, x3 up to so on till xn. Suppose if n is 2, then your variable is x1 and x2, so your matrix dimension will be 2 cross 1, means row into column. All right. So let me tell you, d by dt of x, this is also denoted as x dot. All right. And in the Laplace it is given by x times of x of s. All right. Now integration of x in Laplace, it is given by x of s divided by s. All right. X of s divided by s. So can I write integration of x of t is equal to the Laplace transform of 1 upon s into x of s. All right. Now look here, integration of differentiation of x of t. Everyone, integration of differentiation of this is equal to what? This is equal to variable only. This is equal to variable only. So x dot integration, this is equal to variable itself. So this is important, which you need to know. And one more extra point, from the Mason-Gain formula, you know that if y is the output and let us say x1 and x2 are two input with a gain a1 and a2, then always at output equal to gain product of incoming node. That means y equal to gain a1 with input as x1 plus gain a2 times of input is x2. So always output is equal to sum of incoming node. So these are two important points which you need to know, this one and this one. All right. Now let us move to the question. Look here, there are total two terms of 1 by s. There are two terms of 1 by s. So 1 by s here and 1 by s here. That means we have two state variable in our problem. We have two state variable in the problem. So we will consider this node as x1. So 1 by s. So definitely before this x1 dot will come. All right. So I will take this node as x1 dot. All right. Now x1 dot is also 1 by s is also here. So prior to that, I will consider this node as x2 dot. All right. Now let me write, and you know that x1 dot is equal to x2, as you know that. So everyone, please confirm me, this is correct or not? X1 dot is equal to x2. Everyone, please confirm whether this is correct or not. This node, x1 dot node, is equal to x2 or not? Please, everyone has to answer. X1 dot is equal to x2 or not? In this case, x1 dot is equal to x2 or not? So x1 dot is not equal to x2 here. This is because look here, x2 dot with integrating 1 by s. No, this is not equal. This is not equal to x2. Look here. This is x2 dot na. This will come here after multiplying with 1 by s. This will become, let me change the color itself. This will become x2. Clear? Now in this node, one extra signal is coming. One extra signal is coming. That means at this node, two signals are coming, x2 and minus x1. So x1 dot is minus, x2 minus x1. Have you got the point or not? समझ में आया कि नहीं? Have you got the point or not? That's why I have given you the concept here itself. That means the output is equal to sum of incoming node. So in our problem, there are two incoming node. One is this, and again one is this. That is why the x1 node is equal to x2 x1 times of minus x1. Rasekhar, have you got the point or not? Have you got the point or not? Okay. So excellent, Rasekhar. So this is this was x2 dot, this is x1 dot, and we know that and sorry, this one is x1 also, and now only we got that x1 dot is equal to x2 minus x1. All right, now look here, x1 dot is equal to x2 minus x1. Similarly x2 dot is equal to sum of incoming nodes. So 1 into r, that is r, minus 5 times of x1 minus 5 times of x1 minus 5 times of x1, and again minus 6 times of x1. All right, sorry, x1 dot minus 5 times of x1 dot. So r minus 5 times of x1 dot is x2 minus x1 minus 6 x1. So this value will be equal to r minus 5x2 plus 5x1 minus 6x1. All right, so this is also equal to r minus 6x1, sorry, not minus 6, minus 5 plus 6 is minus x1 plus, or sorry, minus 5x2. So all right, we got x1 dot and x2 dot. So what about y? So y is equal to 1 times of x1 dot, 1 times of x1 dot, also 1 times of x1 plus 1 times of x1. So x1 dot is x2 minus x1 plus x1. So this value is equal to x2 only. All right, so x1 dot, x2 dot, this is 2 cross 1, this is equal to, let me change the color here. So this is equal to 2 cross 2. All right, and x is x1 x2 plus p times of u, as input is only 1 na, so I will write it as u1 cross 1. All right, this is 2 cross 1. So x1 dot is equal to minus 1 times of, can I write this as minus 1 times of x1 plus 1 times of x2. So minus 1 times of x1 plus 1 times of x2. Now x2 dot is equal to minus 1 times of x1 minus 5 times of x2 plus 1 times of r. All right, So minus 1 times of x1 minus 5 times of x2. And here r terms is 0, na? This is 0. So anyhow, input vector is r. So here it will be 1. And y vector, that is y, which is equal to c times of x1 x2. So y is x2 only. That means this is 0 times of x1 plus 1 times of x2. So this will be 0 and 1. All right. So this is your state space model. Let us go back and check whether we are getting this or not. So minus 1, 1, minus 1, minus 5, 0, 1, 0, 1. So minus 1. So look here, this term, that is a11. A11 term is minus 1. But in our problem, but in the given option, no term in A11 is minus 1. Note in A11 is minus 1. That means we have obtained the wrong solution. Is it? No. Is it? No. It is because can I take this node as x2 dot also? This is also the one of the possibility, na? I have chosen this node as x2 also and this one as x1 dot also. That means, sir, we need to find again the whole procedure. No, there is one shortcut. There is one shortcut. Now look that shortcut. Just you need to interchange the A matrix, B matrix, and C matrix, and rest will remain unaltered. So x1 dot, x2 dot, A matrix. Look very carefully, na. X1, x2 plus R and Y matrix as C, x1 and x2. So whenever you come across such sort of difficulty, what you need to do? Just swap the principal diagonal element and off diagonal element. All right, just swap the principal diagonal element and off diagonal element. So after swapping, we will get minus 5 here. This will come, or let me change the color. This will come here. All right, this will come here, that is minus 1. All right, now this term will come here, minus 1. All right, and this term will come here, this is 1. All right, now you need to reverse this also, 1 0. Similarly this one also, means 1 0. So minus 5 minus 1, then 1 minus 1, 1 0 1 0. So let us move back and check the option. So minus 5 minus 1, 1 and minus 1. So this may be correct, but here 1 and 0 should have been come. So this is not the correct option. So minus 5 minus 1, 1 minus 1, 1 comma 0, 1 comma 0, or 1 0. So option D is the correct option for this question. All right, have you got the point? All of you got the point or not? So whenever you come across such difficulty, please use this concept. You will going to get the answer within a 5 seconds after doing this. Otherwise, you need to reverse all the process. All right, so that will consume your time. So please remember the shortcut. All right, now look here. Second, we need to find the stability and the nature of the system. All right, and you know that for the stability we will use the characteristic equation, which is given by determinant of Si minus A. So determinant of Si minus A, this means the A matrix here is this one, na? So A plus 5, then plus 1, here minus 1, S plus 1. This should be equal to 0. So S plus 5 s plus 1 plus 1. This is equal to 0. So s square plus 6s plus 6. This is equal to 0. So so till second order, if no term of s are missing, please be attentive and mark my word. If till second order, if there are no s term are missing and all sign are same, then your closed loop transfer function is always stable. Else we can find from the RS table step s to the power 2, s to the power 1, s to the power 0. So the coefficient of s to the power 2 is 1, then 6, 6 and 0, and 6 will come here. As there is no sign change, your closed loop system is stable. So this option is incorrect, and also this option will incorrect. All right. Now we need to find the underdamped. We need to check whether the system is overdamped or underdamped. For this, we will check whether zeta is greater than 1 or zeta less than 1. So equate. Equate this s square plus 6s plus 6 with standard characteristic equation. So 2 zeta omega n is 6 and omega n square equal to 6. So omega n equal to root 6. So from here we will get zeta as 6 divided by 2 root over 6, and this is greater than 1. All right. So as zeta greater than 1 means system is overdamped. So stable and overdamped. That means option A is the correct option for this question. All right. Now let us go and find the problem third, that is transfer function. So for transfer function, you know the formula. C Si minus A whole inverse B, or alternatively you can use Mason's gain formula. As signal flow graph is given to us now, so you can use transfer function by using Mason's gain formula. All right. So C value is 0, 1, or let me say 1, 0 here. S plus what is A matrix here that we have obtained earlier. So plus 5 plus 1 minus 1 and s plus 1. So here s plus 5 plus 1 minus 1, s plus 1, and B matrix is 1 comma 0 here inverse. So wait. All right. Now once you go and find the process means transfer function or the inverse of the that si minus a whole inverse, you will going to get the transfer function as s plus 1 s square plus 6s plus 6. All right, why it is behaving weird? Yeah, let me check. All right, see here. So once you're going to find this, you will going to get the transfer function as 1, 0. This is s plus 1. Just swap this one. All right. So s plus 5, s plus 1 here, s plus 1 here, s plus 5. All right. And take the negative sign here. in the principle of in the off diagonal element -1 and 1. Then determinant of this is s plus 1, s plus 5, and plus 1, and here 1 comma 0. So once you will going to solve this, you will going to get the option as s plus 1, s square plus 6s plus 2. So rest I will give the rest up to you. You please find this one and please verify whether you are getting this or not. All right. Now let us go and find the last one, which is important one, which is steady state error due to step input. Steady state error due to step input. All right. So the obtained transfer function is s plus 1 upon s square plus 6s plus 6. All right. So this is our transfer function. All right. Last bit, we need to find the steady state error due to step input. Now, anyone, please tell me whether this is closed loop transfer function or the open loop transfer function. Tell me. Everyone, please tell me whether this is a closed loop transfer function or open loop transfer function. Guys, please respond. Please tell me whether this is CLTF or OLTF. Rajsekhar, CLTF. All right. Only one answer. Else? All right. This is CLTF. Now, if nothing information is given about the feedback, please consider the by default transfer function from this as CLTF only. All right. So this is your CLTF. This is your CLTF, and we know that steady state error is given by limit s tends to 0 s times of r of s minus c of s. All right. And else the other expression for this is limit t tends to infinity r of t minus c of t. So this will be equal to r of infinity minus c of infinity. All right. So transfer function, r of infinity means input value at infinity. As in the question, it is given that the unit step response or the unit value, that means magnitude of input at omega equal to at t equal to infinity is 1 only. All right. We need to find the output value, that is c of s by r of s, which is s plus 1 upon s square plus 6s plus 6. So c of s, this is equal to s plus 1 s square plus 6s plus 6, and r of s, that is it is unit step now, so this will be 1 by s. And we know that from the final value theorem, if the system is stable, then we can find the steady state value of the system. All right. So limit s tends to 0 s times of c of s. So limit s tends to 0 s times of s plus 1 whole divided by s square plus 6s plus 6. All right. So substitute the value of s equal to 0, you will get 1 upon 6. All right. So this value, that is c of infinity, we got as 1 by 6. Now substitute in the error formula. So r of infinity is 1, c of infinity is 1 by 6. So on simplifying this, we will get 5 by 6 as a answer. So let us go and check the option. So correct option for this question is option number C. All right. So with this, we have completed the part two of the control system, in which we have covered Bode plot, Nyquist plot, and state space analysis. All right. So we have some time. So if you are having doubt, please let me know. Oh, sorry. This is steady state value. This is steady value. So steady state error is B. Thank you, Michael. So with this, we have completed our part 2. So if you are having doubt, please do let me know, or else I will show you the homework question. Okay. So let me show you the homework problem first. Let me increase the font size. So this is your problem 1. Here you need to find the stability for the system, whether it is stable, unstable, marginally stable, and conditionally stable. All right. Problem 1. Now next is problem 2. Homework problem 2. All right. So in this problem, the Nyquist plot of two transfer function is given, z of s and p of s, and so you need to find the Nyquist plot for the product of these two transfer function. All right. That is of g of s. Now come to next question. That is last problem. So this is some network, and for this network, you need to find the state space model. All right. So all right. If you are having doubt, please tell me. Uh, Raj Sekhar Natraj, how, sir, can you explain how to solve last homework problem? Okay, so in this problem, you need to use the network concept, that is KVL and KCL. Look here, there are there are three state variable. There are or there would be three state variable. The state variable is given by the storing element. State variable state variable is given by number of, or effective effective number of energy storing element. So look here, there are three storing element: L1, L2, and capacitor. L1, this is inductor, and this is capacitor. So inductor will store that what to say that current, and capacitor will store the voltage. So in this there are three storing element. So there will be three state variable, and this you can verify from the option itself. There are three variable, uh, IL1 dot, IL2 dot, and VC dot. So just use the concept of KVL and KCL. You will get the state space model from that. All right. So just use the concept of KCL and KVL. All right. So I guess this sort of problem has already come in the previous year, 2020, and I hope prior to prior year also. So if you want to check the concept, you can go to our website and download GATE 2020 instrumentation, or EC, I guess, instrumentation paper. From that you can check the concept, and from that you can use those concept for this question as well. All right. All right, Rajsekhar, is it clear? So you need to use KCL and KVL concept. Okay, Rajsekhar. So, with this note, let me wind up the session. So, please like and share the session with your friend. And if you have not subscribed till yet, the Gate Academy Hindi as well as English channel, please go and subscribe to the channel. All right. So, all the best for your exam and all the best for your future. Thank you.